Sage Security is up next. Roman's going to talk to us a little bit about some of the challenges in ICS or OT, and solving the access management problems. All right, it's all yours, man. Stage is yours, my friend.
Thanks, Dean. All right, well, happy to be here. Let me just quickly introduce myself and Sage as well. So my name is Roman Arutinov. I'm a founder at Sage. I'm heading up products. My background is really about 20 years of experience in cybersecurity and industrial networking. So I was doing malware protection and data security at Symantec, actually Blue Coat before Symantec for a number of years. And then I got into industrial networking at ABB, where I was running the industrial networking group, really focusing on connecting millions of assets out there across the energy, manufacturing, transportation, and defense verticals as well. Really decided to jump out from ABB and found Sage all really around this idea on focusing on cybersecurity protection, protecting assets, and preventing attacks. Really, I wanted to simplify the security stack and deliver comprehensive protection for the industrial assets. So Sage Fabric, our core product, does that today. We deliver what we call zero trust for the real world. So today we're working with companies in the energy space and utilities, traditional energy as well as renewable energy, defense, manufacturing, transportation, and many other verticals as well. What's happening that's interesting to me is if you look at the pattern of recent attacks, more than 80% of them have to do with a stolen credential, an exposed or stolen VPN access, RDP session, VNC session, that allows the attacker to leverage that access and then move laterally. And the attacks are happening not just are happening through the supply chain as well, through the various vendor ecosystems, supplier ecosystems that exist today and are getting bigger. So looking at the methods we use today to protect our assets and enable access, a few things that jump out right away. I mean, really the industrial assets, as you know, have been designed to be isolated and have been isolated for many years. But then we started to network them. I did that at ABB for a number of years. We quickly realized that, we're struggling using a patchwork of tools that exist today. Tools like VPNs, jump boxes, firewall management, privileged access management solutions. The complexity is getting really out of hand, which leads to vulnerabilities and blind spots. So if we look at that a little closer, what we see today, and what we believe at Sage, is that access management today is really just too vulnerable, hard to manage, and just way too trusting. You have operators typically designed to the Purdue model. In many cases, depends on number of levels. Some may have 3, others may have 6. But at the end of the day, you have OT areas or OT segments, and there could be thousands of assets within there exposed over the same segment. Once malware is in, it could spread laterally very quickly. Some studies have been done that it could spread laterally across the whole entire segment and thousands of assets in less than 10 minutes. We use tools like jump boxes that are Windows machines that are vulnerable themselves. In some cases, we've seen thousands of stale accounts on these types of jump boxes. They're hard to manage. Firewalls and DMZs, actually layers of firewalls with millions of static rules, overlapping rules, and in some cases a rule that says allow all. It takes 6 weeks plus to allow a new firewall rule to be added, for a new application to be deployed, for a remote user to have access to that, to the environment. It's just way too complex and slowing down business growth or digital transformation. Companies that still use VPNs, and the vast majority of them do, are putting users directly into those networks, just like VPNs do. They give you an IP address on the network. Anything on that machine now can spread into the network as well. So administrators having to manage access across a VPN, jump box, specific workstation, and a PLC on a very granular level just becomes a nightmare. It's also very difficult to use for users to have to deal with various tools and various accounts as they're trying to orchestrate their access and get work done. Really a better way needed to be developed that doesn't just allow access, but also protect the operation by protecting the various assets. What we've come up with is an identity-based approach to protect assets and allow access on a very granular level. And what I mean by identities is not just identities of users, but also identities of machines, identities of applications, and even identities of data. And why are we talking about identities in the first place? Well, identities are actually a much more effective way for managing access compared to static things like IP addresses and MAC addresses. Identities are recognizable. They're human recognizable, and it's easy to recognize an identity of a machine by, for example, its name, a human recognizable name, versus just an IP address or a MAC. They're verifiable. They're issued by an authority. They can be managed by that authority and revoked by that authority as well. And they're portable. Unlike IP addresses and MAC addresses, you can use an identity across various layers of the network and utilize it for authentication and authorization. So Zero Trust uses identity at its core. So instead of relying on a network perimeter, you rely on an identity-centric perimeter. So each identity forms its own perimeter, whether that's a user identity or a machine identity, controlling access for which users can interface with machines, which machines can interface with each other, as well as which applications can interface with various devices and machines as well. You can extend that concept even further to create a concept of a data identity and control access as to where that data can go and what type of applications and devices can consume that data. There's also a concept of just enough access and just-in-time access. Access is enabled just in time when it's needed and only for the duration of time that it's needed. With just enough access, meaning that it's a role-based or attribute-based access based on a need and based on a specific attribute at the specific location or function. Zero Trust, applying Zero Trust to industrial world doesn't just mean controlling access north-south, but also controlling access in east-west, user-to-machine access, as well as machine-to-machine access within the site, across sites, from external locations as well, comprehensively across multiple OT domains, IT, and cloud services as well. So putting it all together, the Zage Fabric really delivers that Zero Trust for the real world, protecting assets by controlling all the various interactions across various domains and as well as types of interactions. So what we have here is as a typical deployment diagram. With the ZH fabric, you could see these are laid out as cubes, deployed at the various zones, ZH enforcement points deployed at the lower levels of the architecture. The fabric with the ZH enforcement nodes and the ZH enforcement points at nodes, they form connections with each other automatically using reverse tunnels from lower levels of the architecture to the higher levels of the architecture. So from the more trusting areas to the less trusting areas, and never the other way around. The fabric forms a mesh. There could be multiple enterprises, there could be multiple DMZs, multiple OT sites. The mesh creates an overlay directing access and controlling all the various interactions. Each node in the architecture is an authentication, authorization, and enforcement point, meaning that users that need to interact with assets would use the local nodes in those environments to essentially access the asset through that portal, authenticating with the ZH node using their real identity with multi-factor authentication and optionally multi-layer multi-factor authentication, which ensures that separate identities can be used at each layer of the architecture with separate MFA seeds as well. So access can be created based on specific policy for that user, meaning that user will only see assets that are enabled for that specific user by policy and no other assets. So an employee may see a broader set of assets versus a contractor who only needs to perform work on a specific PLC will only see the specific PLC in their list of assets that are available to them. ZH Fabric orchestrates all the access automatically. So credential accounts on local workstations can be created dynamically on demand with unique credentials on per session basis. ZH enforcement filter, which is deployed in the lower parts of the architecture, works with the fabric to dynamically control access down to individual PLCs. Unlike other access solutions, ZH is able to control access down to individual PLC level. So an account can be injected in a workstation, and then as ZH enforcement form is orchestrated to restrict access down to a specific PLC only for the duration of the time that's required for the work to be performed. The ZH enforcement point is basically an inline filter that gets deployed in front of switches. It can handle multiple devices behind it. We've deployed hundreds of them with customers. I think our biggest deployment to date is over 700 of them with a very large oil and gas customer. The same enforcement point can also control access for machine to machine, creating dynamic segmentation policies in the environment within the site, across the sites, etc. Another interesting point that I'd like to note is the multi-hop architecture that's uniquely delivered by ZH. The ZH Fabric nodes are deployed across multiple levels, and therefore there's no longer a need to manage the various firewalls that are involved. We've seen customers remove millions of firewalls rules, just allow the ZH Fabric reverse tunnels through those firewalls. Again, most of the time there are no rule changes that are needed for that. You can shut down all the various other firewall rules. Firewalls are really not an effective way to manage access. That they create the complexity. ZH's Fabric uses a policy-based approach that's defined centrally and distributed across the whole entire infrastructure so that each node can enforce, authenticate, authorize, and enforce access on a very granular level. Vulnerable protocols, should mention those as well. Protocols like RDP and VNC, and many others. They're never exposed with Sage. We terminate them inside the environment, we emulate them inside of the browser, and we present that to the remote user with inside of their browser. So any malware that may be on that machine can no longer utilize those protocols or the protocol vulnerabilities. In fact, there's no VPN either, right? So that user is always remote. That user is never inside the network, and the malware that may be on that machine is always external, is never inside the operation. There are many other things that we support, like file transfer with scanning, session collaboration for multiple users, shadowing, recording, a variety of other capabilities as well. I did want to touch base on one specific capability that we recently launched. We call it multi-layer identity and access management. What we've noticed is that with many of our customers, they have tens of Active Directory systems across their operation. Their Azure AD Active Directory systems themselves, LDAP-based systems, SAML-based systems, at a variety of levels. There could be an enterprise, a DMZ IDP as well, another IDP for each operational site, and there could be, we've seen customers with up to 50 of them, in fact. It's done for a purpose, for a reason. It's due to high availability nature, as well as many companies are running separate businesses that are fully independent and require control, their own control. And at the same time, it is a part of the defense in-depth architecture, ensuring that there's no central point of failure. So what we did as Sage is create the ability to integrate multiple identity providers across various levels into the Sage fabric, creating a simplified user experience for the user, so that they can use a single interface to access all those assets while utilizing separate identities, separate credentials at each various level, depending on where they are. We've simplified it even further by launching a passwordless approach. We realized that, while creating multiple identities and controlling them is a requirement, it does create complexities for the user. A passwordless approach greatly simplifies that, while still enabling a multi-layer, multi-identity approach. This product is now deployed, available, and with a number of customers. I mentioned some of our customers already, but let me double click on a couple of them. One of them is Kinder Morgan. We recently made an announcement around this. Kinder Morgan is one of the largest pipeline operators, over 85,000 miles of pipeline, moving over 40% of nation's gas products, hundreds of sites across the pipeline with tens of thousands of assets, with connected over various types of networks, anything you can imagine. Local employees, as well as service contractors that need to access various assets to perform maintenance, as well as service companies that need to interface with assets as well. The challenges that existed are controlling access. Many of the assets don't even have credentials. Some that do, it's hard to rotate credentials. It's hard to enable individual or control individual access to the assets, and also prevent from prevent from lateral movement. So they've also recently were under the TSA security directives requirements, which mandated things like multi-factor authentication or compensating controls for multi-factor authentication, rotating credentials, controlling access to assets using credentials, or providing compensating controls similar to credentials for controlling access. So they chose Zage. Zage has been deployed at Kinder Morgan on broad scale, hundreds of sites. There has been minimal impact to operations. The technicians and service vendors use their identities, their real identities now to connect to assets, utilizing multi-factor authentication. Kinder Morgan was able to meet TSA regulations, enable greater control and protection for their assets. A similar customer is a large steel manufacturer, multiple plants. Again, local access is required, as well as remote access is required by employees as well as technicians, down to individual workstations, PLCs, and HMIs. Very little control to date as far as credentials. Many assets don't have credentials. We're utilizing vulnerable VPN, had complex firewall rules, static accounts everywhere across workstations, across jump boxes as well. They adopted a zero trust approach while preserving their defense in depth multi-layer architecture, utilizing Zage's multi-hop technology. They were able to simplify the stack, remove their VPNs, remove their firewall management tools, remove their privileged access management solutions as well, and consolidate all of that into this utilizing Zage Fabric that's been deployed now across over 10 sites and across 2 different geographies. I did want to leave some time for questions as well.
Of course, thanks so much, Roman. We actually do have a number of questions up for you. Just reviewing your presentation, a couple things directly come to mind. Obviously, things like adversary lateral movement, which in my head is possibly stage 1 and is stage 2 of the ICS cyber kill chain specifically. So, working towards detecting that at least, or not having that happen, lateral movement, by using access credentials and access management. So I'm going to jump in with the questions. Are you cool with that?
Yeah, sounds good.
All right, here we go. So here are some of the questions from our live audience. There's a few other ones here as well, coming in over Zoom as well as through Slack. So first question is this. It seems like Zage would be a very attractive target on a network that it's installed on. What does Zage do to harden their solution to ensure engineering reliability and engineering safety, since it's so critical to the functionality of a networked environment in a control system for daily engineering operations?
Yeah, that's a great question. So, and this is something that we spent quite a bit of time on at Zage. So first of all, the whole system is designed as utilizing a distributed architecture. So it's a mesh approach. Each node in the architecture can take over for another. There's no central point of failure. There's no single point of hack or single point of failure. At the same time, if there are network failures and sites get disconnected, local nodes can be utilized on those sites to continue to enforce that, authentication, to continue to require authentication, authorization, and enforce all the various interactions. We actually utilize a consensus approach between the various nodes, so that, and there's a couple techniques that we use for that. So each node utilizes consensus to ensure the consistency of information, data, and authentication and policy data across it. So that ensures tamper-proofing. The other approach we use is what we've invented at Zage, is called the distributed threshold-based encryption, utilizing Shamir secret sharing. It's a
Okay.
technique that's used to encrypt data on disk by moving it around various parts of the disk. We use that across nodes in a distributed fashion, meaning nodes have to work together to, again, unencrypt the data and policy. Enforcement points, they're designed to, I guess, in electrical terms, to fail closed. Software terms, open. So that means that if they lose power, something crashes on them, they are the switch closes, and we don't block the traffic. We allow the interactions to go through. Right? They can be deployed with redundant fashion as well. So there's high availability built in from the beginning, and quite a bit of thinking that's gone into that.
Okay, good stuff. I want to keep going with the questions here because we've got a ton queued up for you. This is great. So question here is, in one of the slides you showed, it looked to be an inbound connection into the control system, into the from the IT network, it says here. Does that rely on the IT Active Directory infrastructure for authentication, or does it have a shared communication with the ICS environment to get access to a PLC in the ICS?
So the way that works is that the connections are all, and maybe I can go back to that slide, but the connections are all originating from lower levels up. So each node acts as a proxy and then hands off to the next one. So there's that session and protocol break that happens at every node. The authentication happens with the Active Directory system that may exist in any specific environment, whether that's in IT or OT. There's multiple layers of authentication that happens.
Okay, so can you give the example of, we need to get access to a safety intermittent system PLC, or maybe an engineering workstation, so lower levels of the Purdue. How does one get access to that exactly? Where does the connection initiate from, and what happens?
So let's say that's a remote user that's coming in from the IT environment. They would open a browser session to a local node in that environment. That local node will then present an authentication screen where you would authenticate using your identity with MFA. It will then show you only the assets you're allowed to access. Maybe that's a workstation here in the OT site and a single PLC per your policy. It will then proxy and relay. Once you select the asset you want to go to, it'll proxy and relay across multiple layers and instantiate a session, temporary session for you on this workstation in here. Dynamically orchestrate as ZTNA enforcement point to allow access to a single PLC that you've selected. And now from that workstation and environment, you can bring up your native application, Studio 5000, RS Logics, and then be able to only access that specific PLC in the environment and no other PLC to do the work. So all of that is presented in the browser. Yep.
In a browser from IT or from ICS or wherever it is, but it's from a browser to ZTNA into the network.
That's right.
Okay. So continue on with the questions here. We've got a few more queued up here. Only got a few minutes left. So you mentioned in the presentation, let me just take a look here at the question. There was machine-to-machine communication that was mentioned. How does ZTNA's solution know if that is expected engineering or ICS traffic, or if it's an adversary conducting internal ICS lateral movement?
Yeah. So the policies are built up front, right? So the policies are zero trust or dynamic segmentation policies. They can be as granular or they can be as broad as you need to build them. So these policies are built from the beginning, so that what we see typically is that you have thousands of assets in a VLAN, but only 3 of them require to be daisy chained or be able to talk to each other. So then you create a policy for that. Then it's pretty easy to see violations to that policy. And in fact, it's, removes those false positives. Once you see an asset that's been blocked per policy, yet trying to access various other assets continuously, something's up with that asset, right? And we'll flag that, we'll bubble it up, we'll create an alert based on this type of behavior. But the policies are created, the policies are enforced, the policies are blocking that interaction, right?
Okay. So to that point there, as we've been talking about getting access to sensitive, I'll say assets inside of a control system network, the question comes around here about, can you elaborate on the Zage platform log data? Exactly what is being logged and what is accessible to somebody protecting a control system? For example, getting access to a programmable logic controller from an IT network, what logs can be viewed to do forensics analysis and incident response?
Yeah, so there's quite a bit of logging that happens there. One of the things that Zage really enables is identity-based or identity aware interaction logs, right? So previously, where there was no, you couldn't tell which user, which interfacing with which asset, especially the ones that you really don't have accounts, vast majority of them. So with Zage, you're able to see information as to which specific identity was interacting with which assets, when, what were they doing. And that information is then bubbled up to the Zage manager through the fabric, and then can be exported. We integrate with various SIMs as well into those products. Some of the things that we could flag is that's interesting data is, for example, an identity or a user that's been accessing an asset from at one site, and then accessing an asset immediately on another site thousands of miles away in a very different, that's identity potentially compromised, or identity or an identity being used to access lots of assets simultaneously. That's another potential threat. Accounts being used from different directions, potentially from different countries, within a very close proximity in time, right? So
Right.
another potential threat. Machines that are doing things against their policy, another log event that we log and bubble up.
Okay, excellent. We're just about on time here right now. So definitely, Roman, want to thank you for explaining Zage to us, understanding about that zero trust kind of approach that someone could utilize for identity management as well. I also want to remind people that if you have further conversations or questions needed for Roman, drop those in the Slack. I'm sure he's going to be able to reach out to you and respond there wherever we can.